Welcome Pure Maths. No, not Pure Maths. Welcome Stats students. We're doing week 10 of our maintenance. We've got a table here, past exam question here. Table summarising the times it took for 112 people to travel to work on a particular day. And we've got to state which time interval contains the median and the upper quartile. So for this I'm just going to go 112 times 0.5 and this is 56. So I'm looking at number 50, the 56th and 57th item of data. So if I'm looking at the frequencies along the bottom, 19 plus 12 gives me 31. So I still need to go plus 28. That takes me to 59. So I know that I'm in this bracket here for median. So the median is in the 15 is less than t is less than or equal to 20 bracket. Now the upper quartile, to find the upper quartile I'm just going to times this by 0.75. So what do I get there? 84, so I'm looking at the 84th and 85th values. So where's that going to be? Well, we know at here we're at 59, so if we add 22 to that we get 81. So you can see clearly that we're going to be in this block here. So upper quartile will be in the 25 is less than t is less than or equal to 40 group. Now we've got to draw a histogram to represent this data. Okay. Let's see, I think I can fit everything on. Now what I might do is, because the gaps are, the intervals are different sizes, I'm going to work out a frequency density for each one. So of course you can remember that the frequency density is equal to the frequency over the class width, and the width is obviously 10 here, so we can say this is 1.9. The next one, the class width is 5, so we just go 12 divide 5, which gives us 12 over 5 or 2.4. The next one is 28 divided by, again it's an interval of 5, so this is 5.6. The next one is 22, and we do it dividing this one by 5, so that's 4.4. The next one is 18, and it's an interval of 15, I think this time, so we're getting 1.2. And the next one is an interval of 20, so we get 0.65, I think. Alright, now what we'll do is, I guess we can go 1, 2, 3, 4, 5, 6. So this is frequency density in this. And I guess down the bottom here we'll have time in minutes. It's a bit messy, sorry. Let's just clean that up. Whoops. In minutes. Try and make it reasonably neat. Okay. And I guess we'll just go 10, 30, 40, 50, 60. Oh, that's perfect. Okay. And so between 0 and 10 we've got a frequency of 1.9. So I'll just do that. And there's our, obviously you're going to have a ruler. And then next one is 2.4. So 2.4, and it's going to 15, so 2.4 would be here. and it's only going across there, and so we'll be down here. And then from 15 across to 20, we've got 5.6, so 5.6 will be up here. Again, no ruler, so I'm sorry about that. And the next one is from 20 to 25, and that's 4.4. So 4.4 would be about there. So just put that down here. Maybe the scale's a bit big, but anyway. 4.4, okay. And then from 25 to 40, we've got 1.2, I think. So that's 1.2 will be sort of here. It'll take us to there. And then the last one is 0.65, and it's going from 40 to 60. So 0.65 would be approximately here. Wait, there's 0.6, 0.65, sort of like that. And then down. And that would be our histogram. I think I've got everything there. Calculate an estimate of the mean time to travel to work. Okay, an estimate of the mean. So let's just take this data down to help us, I guess. Move this up here. And I guess we could think about our mid-interval values. So we've got a mid-interval value of 5, 12.5, 17.5, 22.5, and then, oh, that's 15, isn't it? So 7.5, so what's that, 32.5, and the last one is 50, and then we can find our fx values. So that's 19 times 5 for the first one, so we're getting 95, and then 12.5 times 12, so we get 150 for the next one. The next one is 17.5 times 28, which is 490. Next one is 22.5 times 22, which is 495. The next one is 32.5 multiplied by 18, which is 585. And the next one is 50 times 13. I'm getting 650 for that. Now, if we calculate all of those together, 495 plus 490 plus 150 plus 95, I'm getting 2465. And the sum of the frequency, now I think they told us right at the beginning, 112. So the estimate of the mean would be the sum of fx over the sum of f. In this case it's going to be 2465 over 112. And that's giving us an estimate of 22 minutes, or 22.0 minutes. As an estimate of the mean. Alright, that brings us to the probability question. Got Fabio drinking coffee each morning, choosing Americano, cappuccino, or latte with probabilities 0.5, 0.3 and 0.2 respectively. Okay. If he chooses Americano, he either drinks it immediately with probability 0.8 or drinks it later. Okay, immediate 0.8. Later 0.2. If he drinks cappuccino, he either drinks it immediately, which is 0.6, or later, which is obviously 0.4. And if he chooses the latte, he drinks it immediately with a probability of 0.1. Okay, what's he got against the latte? I don't know. 0.1 or later, which is 0.9. Okay. Find the probability that Fabio chooses Americano and leaves it to drink later. Well, it's 0.5, okay, times 0.2. Well, that's a nice easy one. So 0.01. Okay, and sorry, 0.1. Seriously. Okay, anyway, Fabio drinks his coffee immediately. Find the probability he chose latte. Okay, so if we're thinking about him drinking it immediately, then we're thinking about this branch, and this branch. So the probability he chose latte, given he drinks his coffee immediately. So we can go, this is like the probability of latte, given he drinks his coffee immediately. It's like this, given he drinks his coffee immediately, and we can write that as well. It's the probability of latte and immediately divided by probability of immediately. And so the probability of latte intersecting with immediate drinking is this branch here, 0.2 times 0.1. And then we're just going to pop it over 0.2 times 0.1 plus 0.3 times 0.6 plus 0.5 times 0.8. And when we just chuck that into the calculator, what the heck do we get? Oops, I think I made an error there. I'm just going to start again. Okay, I'm getting 1/30th. Hopefully that's okay. Now the next question is a discrete random variables question. We've got a fair tetrahedral die that has 4 triangular faces numbered 1, 2, 3, and 4, and the score when the dice is thrown is the number that it's on, and we throw it 3 times, and the random variable x is the sum of 3 scores. Okay, so this is a new topic which we've done a little bit in class, hopefully by now, so it shouldn't be too difficult for you. So we've first of all got to show that the probability of x equaling 9 is 10 over 64. So if you think about the ways that you can get 9, your dice adding up to 9 when you throw it 3 times, you could obviously get 3, 3, and 3, or you could get 4, 3, and 2, or you could get, what could you get? Is there anything else we could get here? 4, 3, 6, 9, 4. Oh, we could go 4, 4, and 1, couldn't we? Okay. Now, this one's easy. So 3, 3, and 3 is like 1/4. You've got a 1/4 chance of getting that each time. So it's just simply 1/4 cubed. This one it gets a bit more tricky because you could go 4, 3, 2. Or you could go 4, 2, 3, or you could go 2, 4, 3, or 2, 3, 4, or so you actually find that there's 6 ways of rearranging this. So we're going to go for that one, 6 times 1/4 cubed, because the 4 has a 1/4 chance, the 3 has a 1/4 chance, the 2 has a 1/4 chance, but we can arrange them in 6 different ways. Then finally 4, 4, and 1. There are only 3 ways you can arrange that, right? And here are the 3 ways you could arrange it. So you're going to go 3 times 1/4 cubed. Now, when you do that, you get 10 over 64, I think. We can check that. 1/64, yep. Plus 6, 64, 7, plus 3. Yeah, okay, there we go. There's our 10 over 64. Now, the second part of this is we've actually got to complete the probability distribution table. Well, 12 is easy. There's only one way you can get 12, and that's by getting 4 3 times in a row. So that's 1/4 cubed. Now, to get 11, how can we get 11? 8 and 3. So we could go, for getting 11, we can get 4, 4, 3. And I don't think there's any other ways that you can get that, really. So you can see that you've got 3 options there. There's 3 ways of doing it. So for 11, we'll say 3 over 64. So 3 times 1/4 cubed. 10. How can we get to 10s? We could go 4, 4, and 2. Or we could go 3, 4, and 3. I think that's it. So this first one, you can see it's going to be 3 lots of 1/4 cubed. This one also 3 lots of 1/4 cubed, because there's 3 ways of arranging those numbers. So altogether, it looks to me to be 6 out of 64. Now let's consider 8. Interesting. 8. How can we get 8? We could go 2, 4, and 2. We could go 2, 3, 3. We could go 3, 4, 1. Are there any other ways of getting 8 there? I don't think so. So the first one here, this 2, 4, 2, you can see that there are 3 ways of arranging that. So that's going to be 3 lots of 1/4 cube. This one also is going to be 3 lots of 1/4 cube. And this last one is simply 1/4 cubed. There's only one way of doing that. Oh, sorry, there's not actually. There's actually 6 ways of rearranging that one, isn't there? There's because you can have 3, 4, 1, 3, 1, 4, 4, 1, 3, 4, 3, 1, 1, 3, 4, 1, 4, 3. Okay, so there's 6 ways there. So you add those all up, and I think we've got 12 over 64. And now we've got 6. How can we make 6? 2, 4, 6. We could go 2, 2, and 2. We could go 2, 3, and 1. 6. How else could we get it? We could go 4, 1, and 1. We could go I think that's all again. So this one is just 1/4 cubed. This one is 6 lots of 1/4 cubed. And this is 3 lots of 1/4 cubed. And so we add that up and we get 10 over 64. Last one is 5s. How are we going to make 5s? What are the different ways we can add up to 5? Well, we could get 1, 2, and 3. Or we could get 2, 2, and 1. I think those are the only options. So this one is 1/4 cubed times 6. And this one is 1/4 cubed times 3. So altogether I think it should be 9 over 64. Now what we can quickly do to check that we haven't made a error of some description is just to add the numerators up, and they should all add to 64 if I've done this correctly, because these are the only options we can have. Oh look, I see where I've gone wrong. It's just this last one here. You can see that I said that you could make 5 by adding 1, 2 and 3, which of course you can't, that's 6, so we can ignore that. And so now that will change things. How can we make up 5? 2, 2 and 1, and I guess the other option is 3, 1 and 1, and of course that'll also be 1/4 cubed times 3. So I think instead of 9 over 64, that one should be 6 over 64 as well. You can see the pattern as well. That would have alerted us. Now the last part of this is the event R is sum of 3 scores is 9, and event S is the product of 3 scores is 16, and we've got to determine whether they're independent. Now the rule is if they're independent, then that the probability of R given S will still be equal to the probability of R. In other words, probability of S has no impact on it. So what we need to do here is first of all work out the probability of S. Now how do we get 3 scores product being 16? Well, obviously you can do it with 4, 4 and 1, or you could do it with 2, 4 and 2, and so altogether when we work out the probability of those, I think that's each of them have 3/64th chance, so I think it's 6 out of 64, 6/64th chance. Now the probability of R is scoring a 9, so that's 10 over 64. We did the work for that above, didn't we, over here. Now the probability of R intersection S. Now remember the ways that we could get, there were 3 different ways that we could get 9. The first was 3, 3, 3, so there's that one there, 3, 3, 3. Then we had, what did we have? 4, 3 and 2. 4, 3 and 2. And then the final way was, how else could we get 9? I guess was 4, 4 and 1. Okay, and so that way and this way are an intersection, aren't they? So the probability of R intersection S would be 3/64, I think, and then we're going to pop that over the probability of S, 6/64, and we get 1/2. Now you can see that this does not equal the probability of R. Okay, so just to clarify, this here is this here, and you can see that it does not equal probability of R. Therefore, because probability of R is 10 over 64, therefore they are not independent. Okay, and that's that. Well, I hope that's a nice intro to discrete random variables for the first time for you, with a bit of probability at the end there. Okay, take care team. See you later.